Okay, so in this review, we're going to look at performing the operations on radicals. Basically, you're going to be in these examples for this particular review, you're going to be adding and subtracting. And now, when adding and subtracting, whether it's square roots or cube roots, it's very important you understand what makes radicals like terms. So let's talk about this. So what are like terms with regards to radicals? Okay, so what we're going to look at to determine that is the index and the radicand. Index and the radicand. Those two, for the most part, will determine whether radicals are like terms in these problems. So here's some examples of like terms. And as we go through this, we'll talk about what makes those like terms. Okay, the first one, the square root of 2x, comma, and then 3 square root of 2x. Okay, so you see the word index and radicand. So notice the square root, right? So the index here is 2, the index here is 2. The radicand is 2x, the radicand is 2x. So those are like terms. It doesn't matter what the coefficient is, that number in front. See, that's a 1, that's a 3. Does not matter. What matters is the index and the radicand. The index both have to be alike. So those are both 2's, square roots. And then the radicands have to be the same. Square root of 2x, square root of 2x. The radicand is 2x, 2x. Okay? Let's look at another one. So we have 4 cube root of x, comma, 2 cube root of x. Those are like terms. Cube root, cube root. See the word index? Cube root, cube root. The radicand are alike, x, x. So those are like terms. Doesn't matter that that's a 4 and that's a 2. Does not matter. It's the index and the radicand, for the most part, that will determine whether two or more radicals are like terms. So at some point, as we go through the lesson, as we go through this review, you're going to see that we can combine those into one radical. So they're like terms, we can combine them. It's very similar to when you did something like this, if you recall, 4x plus 5x, see, those are like terms, right? We can write it as just one term, 9x. Same idea. Number 3, you have 5x square root of 2, comma, negative 6x square root of 2. Okay, now we have to be a little bit careful with this one. So remember I kept saying for the most part, you're going to look at the index and then the radicand. Okay, now notice, see the index, they're both square roots, right? Square root of x, square root of 2, square root of 2. The radicands are the same, 2, 2. So I agree, in terms of index and radicand, those are the same. But here's what else you got to look at now. See, there's a variable outside of that radical. So you got to consider that as well. So you see how this is x to the first and this is x to the first? So since the variable's on the outside, you have to look at x square root of 2 and x square root of 2 and compare those. Since x square root of 2 is the same as x square root of 2, those are like terms. So I have 5 of them and a negative 6. Now, compared with this, these are not like terms. Okay, now what if you had this? Now watch, these are not like terms. 6x squared square root of 2, comma, 5x square root of 2. See, compare this with this one. These were like terms because this is x to the first square root of 2, x to the first square root of 2. Here, notice, you see this right here, you have a variable on the outside, so you got to consider that. This is x squared, but over here, that's just x to the first, so that's not the same. So what makes those not like terms is this x squared here and this x. So this x has exponent 2, this x has exponent 1. Doesn't matter that they both have square root of 2. Those are not like terms. For that reason, I have circled. Okay? And then the other one is this. You have, let's say, 4 cube root of 3, comma, 2 square root of 3. Doesn't matter that the radicands are the same. What's the issue? The issue is the index. This is cube root, this is square root. Those are not like terms. You cannot combine those. You cannot write them as one. Okay? So you're going to use those ideas when adding and subtracting. So when adding and subtracting radicals, you will be asking yourself, can I combine those? Can I combine those terms? All right? So let's look at some examples. So let's look at number 1. So number 1, we have 3 square root of x plus 5 square root of x minus 2 square root of x. Now that's the easy kind. This one's easy because notice right away you have 3 terms, 1, 2, 3, right? You have 3 terms. And all those are like terms. See, square root of x, square root of x, square root of x. So all you do is look at the coefficients of those square root of x's. 3 plus 5 is 8. Y'all agree that's 8, right? 8 square root of x. So I can combine those two into 1. Then I'm going to subtract 2 square root of x. Notice those are like terms. So 8 square root of x minus 2 square root of x gives me 6 square root of x. So that's the answer. Number 2, we have 4x cube root of 2x plus 6x cube root of 2x, okay, minus 6x cube square root of x minus 4x cube square root of x. So notice I have 1, 2, 3, 4. 4 terms. I have 4 terms. Okay. Now, you got to ask yourself, can I combine any of them? Well, look, see this right here? See that there's an x on the outside, right? So you got. I'm going to align the x and the radical. So this is x cubed root of 2x. Here's another x cubed root of 2x. So those are like terms. See, x cubed root of 2x, x cubed root of 2x. Now notice here though, this is x cubed square root of x. So that's not the same as these. But here I have another x cubed square root of x. So these are like terms, and these are like terms. So if they're like terms, I can combine them just by looking at their coefficients. 4 plus 6 is 10. So this is 10x cubed root of 2x. Over here, now be careful, this is a negative 6. I have a negative 6 here and a negative 4 here. So that's a negative 10x cubed square root of x. And those are not like terms, so I'm done. This is your answer. Okay? Let's look at number 3. Number 3, I have 2 square root of x minus 5 square root of y plus 3 square root of x plus 3 square root of y minus the square root of x. So I have 1, 2, 3, 4, 5 terms. Now let's talk about which ones are like terms. Okay, so let's start with the square root of x. I have a square root of x right here, right? Do I see any other square root of x's? Right here. So there's another one. Do I see any other ones? Yes, right here. So those 3, 1, 2, 3, those are like terms. So that means I can combine them into 1. Now let's get the square root of y's. I have a square root of y, so I'm underlining it twice, and I have another one. So those are like terms. So I have 3 of them that are alike, and I have 2 that are alike. So let's combine them. 2 square root of x plus 3 square root of x, that's 5, right? 5 square root of x subtract 1 gives me 4. So I get 4 square root of x. So those 3, since those are like terms, I can write it as 1. Now let's do the square root of y's. I have a negative 5 and a positive 3. A negative 5 square root of y and a positive 3 square root of y is a negative 2 square root of y. And notice those are not like terms. Even though they're both square roots, the radicands are different. So that's your answer. That's all you do. So numbers 1, 2, and 3 were fairly easy to deal with. Okay, now let's look at number 4. Now, when we start looking at the others, you're going to have to remember some things that you've done in previous lessons. Okay, so you're going to have to simplify some of these radicals. Okay, so let's look at number 4. So number 4 is where you're going to start doing some work. Number 4, we have 3 square root of x cubed minus x square root of 25x. Okay, that's what I have. All right, now notice two terms, 1, 2. So there's some work you got to do, right? So let's go off to the side and kind of do that. So you see that first term right here? That first term? So let's rewrite it. So I get 3 square root of x cubed. Now let's remind ourselves how to simplify this. So remember, we can simplify the square root of x cubed because the exponent is greater than or equal to the index. Now remember how you did this. You did this. You said 3, and you asked yourself, what's the largest whole number less than 3 that's divisible by 2? And you remember you said 2, right? So you said the square root of x squared times the square root of x. Because remember, when you multiply like bases, you add exponents. 2 plus 1 is 3. And now I can simplify the square root of x squared. So what times itself is x squared? Well, just x. 2 divided by 2 is 1. So this is 3x square root of x. So that goes here now. So that's 3x square root of x. Okay, so you see there's some work you have to do. Now let's look at this one. So I'm going to rewrite this one right here. So I'm going to be subtracting. So just rewrite this, the minus sign, the subtraction symbol. So I have x square root of 25x. Now remember, when just like I did here, I use a product rule. So I'm going to rewrite this as x times the square root of 25 times the square root of x. Now I know that 25 is a perfect square. So the square root of 25 is 5. So I get x times 5. And I know that I cannot simplify the square root of x because the exponent is 1 and 1 is less than the index. So I get the square root of x. But I'm going to rewrite this better. So I'm going to put the 5 in front of the x. So I get 5x square root of x. So that goes here. 5x square root of x. So that's where I'm at. So notice your work you had to do. Now look at this. Are those like terms? Yes, they are, right? This is x squared of x, and this is x squared of x. So now look at the coefficients. I have 3 here and a negative 5 here. So 3 of these and a negative 5 of the same expression, same radical, will give me negative 2x squared of x. So there's some work you had to do there. All right. Notice, though, that all this is very similar. It's the same thing you've done in previous lessons. It's just now you are adding and subtracting radicals. So if you can combine like terms, you combine like terms. Number 5. Number 5, we have this. We have 6 square root of 32x minus the square root of 2x. So 6 square root of 32x minus the square root of 2x. Okay, so let's go ahead and kind of do this on the side. So I have 6 square root of 32x. So using the product rule for radicals, I know I can write this as 6 times the square root of 32 times the square root of x, right? Just like I did this one. And I know that the largest perfect square that goes into 32 is 16. So I can rewrite this as 6 square root of 16 times the square root of 2. 16 times 2 is 32 times the square root of x. And just like over here, I cannot simplify the square root of x. Now let's simplify as much of this as possible. So I get 6 times the square root of 16 is 4, right? I cannot simplify the square root of 2, and I cannot simplify the square root of x. But I also know that since the indices are the same, I can write this as 1 square root just by multiplying the radicands together. So 6 times 4 is 24. And then the square root of 2 times the square root of x is the square root of 2x. So that goes here. So 24 square root of 2x. Okay? And then here you have the square root of 2x, which you know you cannot simplify. So minus the square root of 2x. Notice again, those are like terms, aren't they? Square root of 2x, square root of 2x. You have 24 here. You have a negative 1 here. 24 square root of 2x minus 1 square root of 2x will give you 23 square root of 2x. All right, so that's number 5. So let's look at number 6. Number 6. So number 6, we have this. For number 6, we have, let's see, we have 3 square root of 12 x to the 4th plus x squared square root of 48. Okay? So you see the two terms, right? You have this term plus this term. So let's go off to the side and kind of do the work here. So I'm going to be rewriting 3 square root of 12 x to the 4th. So by the product rule, and remember this is stuff you've had in the past, I can rewrite this as 3 times the square root of 12 times the square root of x to the 4th. And let's simplify the square root of 12. So I know that the largest perfect square that goes into 12 is 4. So I get 3 times the square root of 4 times the square root of 3. 4 times 3 is 12. And I know I can simplify the square root of x to the 4th, right? Because 4, the exponent, is greater than or equal to the index 2. This is easy, though, because 4 is divisible by 2. So the square root of x to the 4th is just x squared. 4 divided by 2 is 2. And it kind of makes sense because x squared times itself is x to the 4th, the radicand. Now, let's simplify this. I get 3 times the square root of 4 is 2 times the square root of 3 times x squared. And you all know that 3 times 2 is 6. You got to do that. And let's put the square root of 3 behind at the end. So I'm going to get 6x squared square root of 3. So 6x squared square root of 3. So that goes here. 6x squared square root of 3. So see, I'm going off to the side. I'm doing the work. Notice how neat this is. Fairly neat. Okay, now let's do the next one. X squared square root of 48. So let's look at the square root of 48. What perfect square goes into 48? All right, well, you agree 16 in it. So I get x squared times the square root of 16 times the square root of 3. 16 times 3 is 48. And I know the square root of 16 is 4, so I get x squared times 4 square root of 3, right? And what I'm going to do is I'm going to rewrite this to where I put the x squared between the 4 and the square root of 3. So it'll be 4x squared square root of 3. So this, remember it's this, so this becomes plus 4x squared square root of 3. Now, do y'all see that this has an x squared square root of 3? And this has an x squared square root of 3. So those are like terms. 6 plus 4 is 10. That's 10 x squared square root of 3. All right, so that's number 6. All right, let's look at number 7. Okay, number 7. Now, number 7, you have this. So you have, number 7, you have the square root of 98x to the 7th plus x square root of 50x to the 5th minus 2x squared square root of 8x cubed. So this is looks a little bit more complicated, and it's a little bit more involved. It is. But notice you have 3 terms, 1, 2, 3. So we're going to simplify each one. So do the work somewhere else. So let's go ahead and do the work here. So let's look at the first one. Square root of 98x to the 7th. So let's remember how we did this previously. So we wrote this, we used the product rule, so I wrote this as a square root of 98 times the square root of x to the 7. Remember that? And then you ask yourself, what's the largest perfect square that goes into 98? And that's 49. So that's the square root of 49 times 2, isn't it? 49 times 2 is 98. Now let's look at the square root of x to the 7. We know we can simplify the square root of x to the 7 because 7 is divisible by 2. I'm sorry, 7 is greater than or equal to 2. Now we know that since 7 is not divisible by 2, we gotta have to rewrite it. So what's the largest whole number less than 7 that's divisible by 2? And remember, that's 6. So I can rewrite this as the square root of x to the 6 times the square root of x. When you multiply like bases, you add exponents. 6 plus 1 is 7. Now, so notice I wrote this as square root of 49, square root of 2, square root of x to the 6, square root of x. So I can simplify the square root of 49. 7 times 7 is 49. Times the square root of 2. I cannot simplify the square root of 2. I know that the square root of x to the 6, 6 divided by 2 is 3, so that's x cubed, right? X cubed times itself is x to the 6. And then square root of x. Okay, now you got to rewrite this, so you remember how you did this. So you see the square root of 2 times the square root of x? Using the product rule, you can write this as 1 square root. Remember that? So I'm going to put that in the endo. So I'm going to say 7 x cubed square root of 2x. So that goes here. So this is 7x cubed square root of 2x. Okay? So here's the work. So remember, I went up to the side and did the work. Okay? This part is from previous lessons. This is a new part. The new part is if you have any like terms, when you do all this stuff, when you have any like terms, you combine them. All right, let's do the next one. So I'm going to do the next one. Let's kind of do this here. So I'm going to do the next one here. So we have x square root of 50 x to the 5th. Okay, so just like you did in previous lessons, I'm going to use a product rule. So I'm going to say x times the square root of 50 times the square root of x to the 5th. And then we're going to simplify the square root of 50 if we can, which we can because the largest perfect square that goes into 50 is 25. So this is x times the square root of 25 times the square root of 2. 25 times 2 is 50. Now I can simplify the square root of x to the 5th because the exponent 5 is greater than or equal to the index, which is 2. But it's not that simple because 5 is not divisible by 2. So ask yourself, what's the largest whole number less than 5 that's divisible by 2? And the answer is 4. So this is going to be so I'm going to write this as this square root of x to the 4th times the square root of x. Okay. All right. Then we're going to simplify each of those. So I have x times the square root of 25 is 5, right? Times the square root of 2. The square root of x to the 4th is x squared. X squared times x squared is x to the 4th. And then times the square root of x. Rewriting this in a better way, you can rewrite this. The square root of 2 times the square root of x, you can write it as 1. I'm going to put everything else in front. So I have 5. Put 5 first. Then x times x squared. See this x times x squared? X times x squared is x cubed. That was important. And then the square root of 2 times the square root of x is the square root of 2x. So that goes here. So I get plus, and then this is 5x cubed square root of 2x. Now let's look at this one. So minus, subtract. Okay, so I'm going to rewrite this one. I'm going to write this one here. So I'm going to rewrite this right here. So I have 2x squared square root of 8x cubed. Okay, so let's simplify this. So we have this radical, so I'm going to rewrite it using the product rule. So I get 2x squared square root of 8 square root of x cubed. The square root of 8 I can simplify because the largest perfect square that goes into 8 is 4. So that's 2x squared square root of 4 square root of 2. So square root of 8 is square root of 4 square root of 2. 4 times 2 is 8. I can simplify the square root of x cubed. The largest whole number less than 3 that's divisible by 2 is 2. So I can rewrite this as square root of x squared square root of x. Okay. So now let's go ahead and see you have a bunch of factors here being multiplied together. So let's simplify as much as we can. I can simplify this one and I can simplify this one. Square root of 4 square root of x squared. So here's what I get. I get 2 times x squared times 2, square root of 4 is 2, times square root of 2 times square root of x squared is x, right? X times x is x squared. 2 divided by 2 is 1, times square root of x. And I know now that this 2 times this 2 is 4. This x squared times this x squared times x is x cubed. And then this square root of 2 times this square root of x is the square root of 2x. So this is this. So now I'm going to rewrite this here. So minus 4x cubed square root of 2x. So notice all of this right here simplifies to this. But notice the work you had to do. So there's some work you had to do to get to that point. But the point is that this work is nothing new. That's what you've had in previous lessons, simplifying radicals. Now, here's a new thing, though. The new thing is for you to notice that these are all like terms. X cubed square root of 2x, x cubed square root of 2x, x cubed square root of 2x. So look at the coefficients. 7 plus 5 is 12. 12 subtract 4 is 8. So you get 8x cubed square root of 2x. And that's your answer. Okay? All right, let's do one more. So here's number 8. So number 8, you have this for number 8. So we have, let's see, this will be number 8. Okay, number 8. All right, you have 5 times the cube root of x to the third y to the 10th minus 3xy times the cube root of 27 y to the 7th. Okay? All right. Now let's go off to the side. So you have two terms. You notice right away they don't look alike, but you got to try and simplify. So you got to simplify first and see if you can combine anything. So let's go off to the side and write the first one over. So I'm going to go off here and write the first one. 5 times the cube root of x cubed y to the 10th. Okay, so according to the product rule, based on something we've learned already in previous lessons, I can rewrite this as 5 times the cube root of x cubed times the cube root of y to the 10th, right? And I know right away I can simplify the cube root of x cubed because this is 3 and this is 3. So 3 divided by 3 is 1. So that one's simple. That's just 5 times x. So the cube root of x is just x. X times itself 3 times is x cubed. See cube root? Now let's look at this one. I can simplify the cube root of y to the 10th because 10 is greater or equal to 3. But 10 is not divisible by 3. So you got to ask yourself, what is the largest whole number less than 10 that's divisible by 3? And that is 9, right? So I can rewrite this as the cube root of y to the 9th times the cube root of y. 9 plus 1 is 10. I can simplify this. Go ahead and do that now. So I get 5x. The cube root of y to the 9th, 9 divided by 3 is 3. That's just y cubed. Y cubed times y cubed times y cubed is y to the 9th. And then times the cube root of y. And so there's nothing else I can do. So you answer. So I can rewrite this as 5x y cubed cube root of y. So that's going to go here. So 5x y cubed cube root of y. See that? Minus. Now let's do this one. So let's go off and put that one here. So 3xy cube root of 27 y to the 7th, right? Okay. So let's try and deal with this cube root right here. So according to the product rule, I can write this as 3xy times the cube root of 27 times the cube root of y to the 7th. Okay? And look at this cube root of 27. You all know that 27 is a perfect cube. What's a cube root of 27? Well, what times itself 3 times is 27? Well, that's 9, right? So right away, I know, so far I have 3xy times 3 times, all right, let's talk about this. I can simplify the cube root of y to the 7th because 7 is greater than or equal to 3. But it's not that simple because 7 is not divisible by 3. So think, what's the largest whole number less than 7 that's divisible by 3? And that's 6. So I can rewrite this as a cube root of y to the 6th times the cube root of y. Y to the 6th times y is y to the 7th. Now I can simplify this now. So I get, oh, and also remember that 3 times 3 is 9. So right away, this is 9, right? So I get 9xy times the cube root of y to the 6th is y squared. 6 divided by 3 is 2 times the cube root of y. Okay, now look at what you have. Y times y squared. So you can go further with this. You need to. So I get 9x. Y times y squared is y cubed times the cube root of y. And that's all you can do. You cannot do anything else. I cannot simplify the cube root of y because the exponent is 1 and 1 is less than the index. So this simplifies to this. So I'm going to rewrite this here now. So minus 9x y cubed, cube root of y. Now look, are those like terms? They both have cube root of y's, right? But they also have variables on the outside. So you got to look at the variables. This is x, y cubed. This is also what? X, y cubed. So you have x, y cubed, cube root of y. And you have x, y cubed, cube root of y. So now they're like terms. So I can combine them as 1. 5 and a negative 9 is a negative 4. So I get negative 4 x y cubed, cube root of y. And that is it. All right. So the idea of combining like terms is the new part, but everything else that you dealt with, all that work you did on the side, that's just information, that's just knowledge that you had from previous lessons. Okay, so that is the idea of performing indicated operations. So that's where you're adding or subtracting and then combining like terms. So that's the end of this review.